Look at how to figure out the hybridization in a molecule. So the first step that you need to do is to draw the Lewis structure. So C2H6, we've got, let's see, 8 valence electrons from the 2 carbons and 6 from the hydrogen, so that's 14 your picture should show. So you connect everything with a single bond. Okay, wait a minute here. So we got 2 carbons and 6 hydrogens. Okay, so you count 2, 4, 6, 8, 10, 12, 14. Okay, so 2, 4, 6, 8, 10, 12, 14, that matches my picture. So, and everything has the octet rule satisfied, everything has 8 around it, except hydrogen only has 2. Alright, now, to figure out the hybridization, you've got to be able to count the domains, okay? Now, so, here's how it goes. So, if you have the domains, okay, so if there are 2 domains around an atom, that means it's sp hybridized, because one s and one p adds up to 2 domains. If you have 3 domains around something, it's called sp2 hybridized. 2 plus 1 is 3, and the maximum for sp hybridization will be 4 domains, which will be sp3. Now, the way that I count domains is just to think about like the electron dot structure for an atom. Like any atom, it has a possibility of 1, 2, 3, 4 domains. 1, 2, 3, 4. So if it says what is the hybridization on one of the carbon atoms in a molecule of C2H6, I just count how many things are around the carbon. So I count, and there's 1, 2, 3, 4 things around the carbon. 1, 2, 3, 4. So it needs 4 domains. So the answer is sp3. Okay, so you can say that this carbon is sp3 hybridized. Now you could look at this carbon, it's exactly the same. 1, 2, 3, 4 domains. It's also sp3. Now, here's a different Lewis structure. So it's C2H4, and if you were to draw that one, you'll see that there's a double bond here. And what we're going to do is we're going to count our domains again. Remember, if there's 2 domains, okay, so if there's 2 domains, then it's going to be sp3, it's sp2 because 2 plus 1 is 3, and if there are 4 domains, then it's going to be sp3. 3 plus 1 is 4. So if we want to do one of the carbons, we count how many things are around it. So we count 1, 2, 3. So there are 3 domains, and so the answer for this carbon is sp2 hybridized. Alright, let's try another one here. Okay, so this one is C2H2, and when you would draw that one, you would find that there's a triple bond with 2 H's on the side. Okay, wait a minute here, did that all wrong. Okay, so I gotta erase that. Let me erase. Alright, and so I need to go back. Alright, so we got 2 carbons. They're triple bonded. There's a hydrogen on the end. And anyway, this one over here does not belong. Okay, like that. So never can triple bond hydrogen. Okay, so now this is what we should have here. Alright, so we're going to count how many things are around carbon. So the way I look at it is the easy way is you just count. There's like 1, 2, 3, 4 possible domains around carbon. And so you count, there's nothing up here, but there's 1 domain here, nothing down here, and 1 domain here. So of the 4 possible domains, we're only using 2 of them. And so it would be sp hybridized, because we're only using 2 of the domains. Alright, so let's try another example here. Alright, so let's say we had something like this right here. So let's say we had ammonia. So if we drew the Lewis structure for ammonia, you would see that it would look like this. Alright, and so if they said what's the hybridization of the nitrogen atom in ammonia, you count how many domains are being used. And you count 1, 2, 3, 4. Okay, the maximum, just look at how many things are around it. You do have to count lone pairs. And so this would be SP3, because you need 3 plus 1, you need 4 domains. So the S is 1, but they don't usually write it. So it's 3 plus 1 is 4. 1, 2, 3, 4. Now, look, I had to count the lone pairs. They have to have a domain. So you have to count those. Okay, looking back, look at how I counted the double bond, though, when I did the carbon or triple bond. I only counted it as one domain, because there's only two, the electrons are only on 2 sides of the carbon. Alright, let's try another one here. Alright. So let's say we had one like H2O. So we have H, O, we got lone pair, H. Okay, and somebody said, well, what's the hybridization of the oxygen in water? So what you could do is you would just count how many things are around the oxygen. You would count 1, 2, 3, 4 things. So that also would be sp3, because you're using all 4 sides of the oxygen. You could kind of think of it like this here. You have a lone pair, one there, and then a hydrogen comes here, and a hydrogen comes here. So you have to, you're using all 4 sides, so you need 4 domains. 3 plus 1 is 4. Okay, let's do one more here. Alright, so let's try one like this here. Let's try ozone. We got O, like that, and this one's double bonded. This one would need 2. This one would need 2, and this one would need 2 here, like 6 around there. Okay, so that's the structure of ozone. So let's say somebody said, hey, what's the hybridization of this oxygen right in the middle? Okay, so you got to think about, well, how many sides does it have things around? It has it around 1, 2, 3 sides. So this oxygen right here, that's going to be sp2 hybridized. How about this oxygen out here on the end? Well, it has things around 1, 2, 3 sides. It's going to need 3 domains also. That would be sp2 hybridized. What about this oxygen right here? 1, 2, 3, 4. So it has 4 domains. So it's going to be sp3 hybridized. Okay, so the trick to this is just counting the domains. Alright, think of like a Lewis dot structure. Think of that first. So just think about like how many sides can something have things on? Well, it can have things on 4 sides. So it has things on all 4 sides, it's sp3. If it's only on 3 sides, it's sp2. And if there's only things on 2 sides, it's sp. Alright, that's it.